In this video, we're now beginning working with the graphs of our radical functions, but we're going to focus on the transformation. So how does it change from the parent or original function? So first, we're going to be using Desmos. So make sure you're set up with Desmos Graphing Calculator, just so that you can see what we're talking about when we have the parent functions or the original function. So when you graph the square root of x, so when you graph the square root of x, here is what that looks like. So we're going to go ahead and do a quick sketch, but notice how the square root of x, it's like a half graph almost, how we start here at 0, 0, and then go upward and to the right, on and on and on. So creating that quick sketch, and I notice I'm here at the point 1, 1, 4, 2. So that's pretty much kind of getting that idea of where we are there at least, and then just kind of estimating. So here at 0, 0, 1, 1, and 4 2s. And then I'll just kind of create that sketch here. So that's kind of like our half graph. Then go ahead and graph the cubed root of x. And if you don't remember to graph cubed root of x. Now I've already graphed it, but again, to show people, just in case if you don't know, remember, you click on the keyboard, then you have to click on functions and scroll all the way down and then click on this button here, that N radical, and then it's going to let you type in the 3 for your index. So that's how you get to the cubed root. But this is now what the cubed root looks like. So it's kind of like our radical, like half graph, but kind of put together. So it's still going now in both directions, constantly going up. But here, notice how that middle point is at 0, 0, 1, 1, negative 1, 1. So we're going to go ahead and create that quick sketch here of our parent function. So that is the cubed root. So it's kind of like a little squiggly going through these points here and then continuing on. So that's the parent function. So what we're going to have students do in the lesson, and you guys also do the same thing, is pause the video and graph these in Desmos and compare them to the original function. So what I mean by is this. We're focusing on the square root. So go back to making sure in the first line you keep the square root of x. Now I've already done all of it, but one at a time. So instead of keeping the cubed root of x, go ahead and then type in so that you see the two graphs at the same time. So go ahead and pause the video and then record or write down what are the things that you notice, what happened to the original graph, and then let's see what you get. And here we go. So with the first one, the square root of x, but then the plus 4 on the outside. So here, if you compare, well, what do you notice? Well, it looks the exact same. It just got moved up 4 units. It went from 0 to now starting here at 0, 4. So basically, you could have put that it moved up 4 units. So then the square root of x plus 4, but notice how that x plus 4 was on the inside. So let's see what happened here. Well, notice how it looks the exact same, but now it got moved 1, 2, 3, 4 units. See how it's at negative 4? 4 units to the left. So this is now moving 4 units, but now to the left. So keep that in mind. What do you notice? Well, if the value was outside, that is your up. So guess what it means if this were a minus? Guess what it would move? Down. So if this was 4 units to the left, now notice, see how it's left, but it was a plus? That means if you need to write this out, it's like the opposite. Because you would think if it's plus 4, you would go 4 to the right, but we went 4 to the left. So it's going to be the opposite inside here. Now this one, so with our negative, so first was outside. So here we go. So notice how it was the exact same graph, but it just got flipped over the x-axis here. So it flipped over the x-axis. So then what do you think would have happened maybe if you had the negative now on the inside? Well, let's see maybe now if you think that's going to flip over the y-axis now, right? And there you go. Notice how it's the exact same, except it flipped over the y-axis. So this is flip now over the y-axis. And so now let's talk about these last two transformations. So when you graph the next one, so with the two times on the outside. So notice how here's the original, and it still starts at the original point. So it didn't move anywhere, right? But notice how the graph, it's almost like it got stretched upward. So it moved up, like it got steeper. So it got stretched and pulled. It got moved or pulled upward. So I could just say almost like that. Oops, sorry. How it got like stretched up. So if this were a fraction, then we could say that it would get stretched downward, right? So stretching upward. So then the next one here with the 1/2 on the inside, now notice it's again, same graph starting at the same spot, but it's now like below it, like as if it got flatter, right? So if you think about it, it's almost like when you take a string, if you think about it, when you take a string and you pull it on its side and pulling it sideward, what happens? It's like the string gets tighter and it gets flatter. So think about this like it's like that string, right? We pulled onto it and made it flatter. So this is, if you think about it, like it's a stretch, stretching that string, but maybe stretching it outward, like to the left. So stretching it out to the left or to the right. So we're stretching it almost as if we were making it flatter, like a flatter line. So now there's some of this we're going to also make sure to kind of convert and change to mathematical vocabulary. Sorry, guys, as that was my door. Hold on one second. There goes my dog. So here's kind of like the mathematical. Notice how we're using and talking about these variables. These variables are always going to be used when we're talking about the transformation. So if you also notice how we'll be using those as we're labeling in this table here. So notice how when we had that negative on the outside, right? See how when we had the negative on the outside, what happened to our graph? It flipped over the x-axis, but we're going to use reflection. So it reflected, but over the x-axis. So that means here when the negative is inside the radical, let's not say flip, but it reflects now over the y-axis. Now I'm going to skip down and save the vertical and horizontal stretches last. So now if you recall, we did that square root of x plus 4, right? Where it was on the outside, which is our value of k here. So again, going back to our equation, see how k is what's on the outside? So again here, k on the outside. When we had that square root of x, but plus 4 here on the outside, so there's your k. Notice how when you added 4, it moved up. So when you have that K here, we're talking about up and down. So that means here, if I have plus 3, just like how we had the plus 4, this means this is going to go up 3 units. So then again, if this is a minus 4 on the outside, our value of K, then that means we're not going to move up, but we're going to move down 4 units. So then when it was on the inside, go back to what we talked about here. So see how it was x plus 4 on the inside, but we said units to the left. So remember, opposite. So now when it's on the inside, it was the opposite. So that means here, that is our value of h. Now here, see, that's why it's the opposite, because the original format is x minus the value. That's why we're taking the opposite, because the format is x minus. So if this is x minus 2, we're used to saying as if this is 2 units to the left, but because it's the opposite, we're moving 2 units to the right. Then if this is x plus 1, this is 1 unit, not to the right, but 1 unit to the left. So again, if you need to make a note of that, remember that this is the opposite when it's inside of the radical. So now let's talk about the vertical. See how with the value A, notice how A, what we're now talking about here is that value on the outside. So like we did 2 times that. And we talked about how it stretched upward, the graph stretched. So really, this was our stretch. Instead of up, think about up and down, which is your vertical. So this is a vertical. Now again, see how it's greater than 1? 6 is greater than like 2. So this is a vertical stretch, just like when we had that value of 2. So then what do you think that means when you now have a fraction outside? So it's still outside, so it's still vertical, now a vertical shrink or compression. So then the next one and last one, this is a little different. Again, notice how we're going to think kind of like opposite on the inside. So this format is actually 1 over b. So it's already in fraction form. So if you recall here, we had a fraction already as if it was stretched like to the right or it was flattened when we had a fraction. So this again means, again, left and right, that's your horizontal. So with a fraction, this is again a horizontal fraction. So horizontal stretch because we're stretching it out, right? Like the string. However, let's practice and also make a note of that because this is actually where B is equal to, not 1/5. Because see how the form is already as a fraction? Well, if this is 1 over b or 1 over 5, then what is b? Well, b is just 5. That's what makes this 1 over 5. That means here, if I have a whole number inside, so again, horizontal on the inside, then this is going to be now the whole number is going to be a compression. But that's because b is not equal to 3. B is equal to the opposite. So b is equal to 1/3. So if you really want to make a note of this, notice how on the inside, everything, whether it was the horizontal or even here inside our parentheses or with that value of h, this has to do with our horizontal or left and right. And on the outside, and it also has to do with opposite. So think opposite inside. Then here on the outside, we have our up and down, because remember, up and down is vertical, but that's not opposite, that stays as is. So now as we're going through these examples, I'll also even show the graphing, but if you ever need to, go back to your notes or go back to the table here to see what the transformations are. So let's identify the transformations first and then graph them to see if you're correct, right? Remember, the parent function is here. So we have our square root. So notice how we have x minus 5 on the inside. So if you remember, inside had to do with horizontal, left and right, and opposite. So if it's x minus 5, I'm going to save 5 units, not to the left, but to the right. Then notice how the 2 here, this a, is on the outside, dealing with our up and down, or in this case, vertical. So this is a vertical, and it's greater than 1, so vertical stretch, where A is equal to 2, so by a value of 2. So now let's actually check to see if we're correct. Graph it. Did we move 5 units to the right? Did we get steeper? Did we stretch it upward by a factor of 2? So let's go here and graph it. And here we go. Notice how we start now here at 5. So we moved 5 units to the right. And notice how it got stretched upward. It did, the graph got steeper. So again, we do have that graph here of moving 5 units to the right and then now being vertically stretched. So then here we have multiple things. So if you need to, let's just read it left to right. Well, we have a negative, but on the outside of the radical. So even if it's a cubed root, it's all going to be the same. So if I have a negative on the outside, so that negative on the outside means it's a reflection over the x-axis now. So we have a reflection over the x-axis. We also have now inside of the radical. So remember, you have a fraction. So that means that this is a horizontal. And remember now, because it's already a fraction, b is equal to not 1/3, but b is equal to 3. So because it is another greater than 1 value, this is a horizontal stretch. So we're stretching it, right? Because b is greater than 1. But we also have inside x plus 2. So remember, plus on the inside, remember everything inside is opposite. So this is not 2 units to the right, but 2 units to the left. Then notice how you do have that 7 here, minus 7 on the outside, which represents your vertical, your up and down. That means here that this is 7 units down. So now let's check. We're talking about moving to the left and down, reflecting over the X, and it's a horizontal stretch. So it's like we're flattening the line or the graph here. So let's see if we're correct. Oh, and then let's actually compare to the original so you guys can see. And here we go. So there you go. Notice how it did. Our graph here got reflected. We started off here at 0, 0, then it got moved 2 to the left and then down, 7 units down. So notice how starting at that center of 0, 0 is now here at -2, -7, because we moved 2 to the left and 7 down. Notice how our graph is also flatter as if we had that horizontal stretch. So everything was matching here. So go ahead and pause the video and try this one on your own. And here we go. Notice how here, right, anything that's a value on the outside has to do with vertical or up and down. Now notice that A is equal to 1/4, which means that this is a vertical shrink or vertical compression because now it's less than 1, the value of A. But here, again, the +3 on the outside means we move 3 units up. Then the negative is now on the inside. Think about it like horizontal. So if I were flipping horizontally, that means we flip over the y-axis. So reflect over the y-axis. So again, notice how that negative on the inside. And then if you want to, we can check our graph here and let's see. So I'm going to go back to the original parent that we had and then compare. So there you go. Notice how here we reflected over the y. Now notice it's also been vertically moved down and we moved up 3 units. So everything matches. Then the last examples, we're going the other direction. So you're given the original. So we're starting with the cubed root of x. We're compressing vertically by a factor of 1/2. So remember, vertical means anything on the outside of the radical. Then translated 5 units to the right. Now this is horizontal, so this is going to be on the inside of the radical. But then again, here's a down, which is vertical. So again, this is on the outside. So how is this going to look? So we have the cubed root of, well, here we have a vertical compression, so outside, so factor of 1/2. So A is equal to 1/2. Then we've got translate 5 units to the right, which means it's on the inside. But remember, inside is opposite. So this is not x plus 5, but x minus 5. Then 2 units down, which again is vertical, so outside, because we're going down, -2. So if you need to, think about the vertical again as the outside, horizontal is the inside. So now let's look at the next example. We're talking about here reflecting the square root of x over the x-axis. So if you recall, if I'm reflecting over the x-axis, we're flipping vertically. So this is another vertical, which means this is going to be on the outside. So again, keep in mind that reflection showing on the outside. Stretching horizontally by a factor of 3. So now that means that this is on the, oops, sorry, as I started writing outside, this is on the inside. But remember, this is going to be our tricky one, so we'll get to that. And translating one unit to the left, which is again another horizontal, which is on the inside. So remember, right? Vertical is outside, horizontal inside. So here I've got the square root, reflection over the x, but because that's vertical outside, so I need that negative on the outside. Then we have a stretch horizontally, so that's going to be on the inside. But now remember, anything inside is opposite. So this is not 3, but 1/3. Then 1 unit to the left. So again, inside in parentheses to keep the 1/3 separate because this is inside, not x minus 1, but x plus 1. Go on and pause the video and try the U-try on your own. And here we go. So again, you're reflecting now over the y-axis. So again, y-axis, this is the y. So if I'm reflecting, it's horizontal, right? Because it's like we went to the left here. So if this is a horizontal reflection, if you think about it, then this is again on the inside. Stretch vertically. So now vertical is outside by a factor of 7. And translated 6 units up, which is a vertical move, which is again going to be on the outside. So here we go. So talking about that square root of x, but notice how whenever it's reflected over the y, which is inside, so I need negative x. Then we have a vertical stretch, so on the outside, that value of a is now 7. And 6 units up, which means now we're moving up, so add 6. So this is our new function showing those transformations.